All right, let's dive right into this explainer where we're unpacking Chapter 10. We're going to be bringing foundational math concepts like currency, addition, and subtraction to life through a vibrant, exciting day at the fair. Math isn't just something that happens on a chalkboard, it literally happens every time we step out the door, especially when we're out having fun.
Just look at this fantastic fairground scene. You've got kids on the merry-go-round, the toy train, the giant Ferris wheel. But here's the thing, it's not just a place for rides. It's actually a giant, real-world math playground just waiting to be explored. Every time a ticket is bought or a snack is purchased, money changes hands and mathematics takes center stage.
So, our journey starts with a girl named Ruple. She arrives at the fair with her friends, totally ready for a day of fun, and her mom gave her exactly 50 rupees. If you've ever been to a fair, you absolutely know that feeling, right? Having that spending money in your pocket, trying to decide which rides and treats will give you the most bang for your buck.
Now this is where it gets interesting. After Ruple enjoys her absolute favorite rides, a friend notices she only has 8 rupees left in her hand. And that sets up our very first mathematical mystery of the day. How much money did she actually spend? Most of us might immediately try to subtract 8 from 50 in our heads, but there's actually a really intuitive, visual way to figure this out. Instead of traditional subtraction, let's see how Ruple's friend uses addition to find the difference. By stacking the amounts from her remaining 8 rupees all the way up to her initial 50, it becomes so incredibly clear. First, you add a 20 rupee note to the 8, which gets us to 28. Add another 20, we're at 48. Finally, just toss in a 2 rupee coin to hit the total 50. By adding those middle steps together, 20 plus 2, we instantly see she spent exactly 42 rupees. It's a fantastic real-world mental math trick.
Moving on to our next section, pop balloons, win money. Let's step away from the rides for a second and try to win some of that money back.
Meet Matru. He's playing one of those classic carnival games where popping balloons earns you cash. But notice how he isn't just throwing darts randomly. He's thinking hard, strategizing about how to maximize his winnings. It really goes to show that a sharp mathematical mind is your best tool at a fair.
Here's the basic rule of his game. If he pops a single balloon, he might get 3 rupees. But the real puzzle begins when we realize the differently colored balloons hold different values. To win the big prizes, he can't just aim blindly. He has to deliberately combine multiple balloons to hit exact target amounts.
So the whole challenge comes down to figuring out exactly which combinations of differently colored balloons he needs to target. The game dares him to make specific amounts, like 17, 22, or 31 rupees. To get 31, for example, he can't just pop a bunch of 3 rupee balloons. He has to analyze the board, understand the value of each color, and use his addition skills to hit those high numbers right on the nose. Taking a quick break from the games, let's jump into our next section, many ways to pay, because handling money is literally one of the most important everyday math skills we can develop. This is such a brilliant illustration of a core currency concept. Here you see a shiny 10 rupee coin, actually it's the one celebrating the 75th year of independence, right next to a standard 10 rupee note. They look completely different, they feel different, one jingles in your pocket and the other folds in your wallet, but mathematically, they hold the exact same purchasing power. Value isn't about what the money looks like, it's about what it represents. Which leads us to a pretty fascinating question to test your logic. Imagine you're at a stall and the vendor asks for exactly 66 rupees. How many different combinations of notes and coins could you possibly pull from your pocket to hand over that exact amount? Think about it for a second. This wheel perfectly shows the incredible variety of ways to solve this exact problem. It's like a giant puzzle. You could use a 50 rupee note, a 10 rupee note, a 5 rupee coin, and a 1 rupee coin. Or, looking at another slice, you could use 3 20 rupee notes, a 5, and a 1. You could even just use a massive pile of 10s and smaller coins. There is no single right answer here, and this visual beautifully captures how flexible numbers can be. All right, as our virtual day at the fair starts to wind down, let's hit our final section, real-world math challenges. Let's take these skills and apply them to some rapid-fire shopping scenarios. First up, we've got Jand. He's shopping and spends 25 rupees on pens and 40 rupees on notebooks. We just need a quick bit of addition here. By breaking it down, adding the 40 to the 20 to get 60, and then adding the 5, we quickly see his total spent is 65 rupees. Easy peasy.
Next, we're moving from combining totals to comparing amounts. We know Mira has 43 rupees, and Kanika has 14 more than Mira. The crucial takeaway here is recognizing that the phrase more than means we need to add. A quick addition of 43 plus 14 clearly shows us Kanika is holding 57 rupees. Then there's Vivek, who's doing a quick grocery run for bread and chocolate. The bread is 30 rupees, the chocolate is 60. This is a perfect example of how quickly simple round numbers ending in 0, add up. 3 tens plus 6 tens equals 9 tens. So Vivek needs exactly 90 rupees. Finally, a Jay's market trip gives us a super clear-cut, real-world subtraction problem. He started with 58 rupees and spent exactly 48 rupees. Because the 8 in the ones column cancels out perfectly, he's left with an incredibly easy-to-calculate balance of just 10 rupees. To wrap up our explainer on Chapter 10 today, I want to leave you with a quick challenge. Next time you go out shopping, try mentally tracking your total spending, just like we did today. Oh, and while you're at it, take a look around. Have you noticed how many people are completely skipping physical cash these days and just tapping their mobile phones to pay instead? The math stays exactly the same, but the way we interact with it is evolving every single day. So, how will you track your totals next time? Keep calculating and stay curious.